Up until now, basically, if I showed you a piece of video, you could pretty much trust that it's authentic because it was really hard to forge video. But the world we're moving into is a world where actually creating videos of events that never happened is actually quite easy.
And all these recent developments in machine learning, deep learning, information processing, computational imaging have equipped us with tools for synthesizing fake images and video. And put in the wrong hands, this is terrifying.
If you can't have trust in the videos, images, and sounds that you're observing, then how do you make decisions? How do you agree on the facts?
The problem of image authentication is extremely resonant with discussions we've been having here at the Electrical Engineering Department at Stanford. We want to understand electrical engineering in the 21st century and to figure out what are the kind of problems that we should focus on.
And so there's definitely a very, very strong need for providing authenticity for all digital content. And the Starling project is exactly intended to fix that gap.
At the Shoah Foundation, the importance of our mission pushes us to the edge of technology. We constantly have to innovate. When we co-founded the Starling Framework with Stanford, our goal was to make sure there was an infrastructure that everyone could participate in. As we speak, the internet's evolving. We want to do our part to make sure that the innovations that are being developed are moving towards a good cause.
So we have three modules to what we're doing with the Starling Framework: capture, store, and verify.
In the capture phase, when you take an image or a video, it basically uses trusted hardware on the phone to sign the image that I just took. That image then goes through the storage phase, where the system will give you what's called a proof of replication. So you can verify that the image, in fact, has been replicated many, many times, and you have guarantees for data availability, data authenticity, and so on. And then there's a human verification phase later on where someone can look at the image and further attest that it is an image of the event that's claimed to have been taken. And when a newspaper presents the image to its readers, their browser can look at the JPEG file and authenticate it for them, so they're guaranteed that they're looking at an image that captured a real live event and not some sort of a tampered image.
The humans are always in the loop. From the person taking the photograph to the person that's analyzing the photograph, all of them have immense responsibilities. And really what we're doing is providing a way for cryptography to help strengthen people as they take on those responsibilities.
What's ambitious about this effort is that we're using all of these decentralized systems to try and authenticate images at the source.
Now, decentralized systems are much, much, much harder to build, and that's what blockchains come to do. Blockchains are still very young, the technology is moving and evolving rapidly, and so it's a wonderful area to experiment with new cryptographic tools. Right now, the focus of the public, I think, is specifically on the cryptocurrency aspect of blockchains. But blockchains are way, way, way broader than just cryptocurrencies. There's a bit of a misappreciation of everything that the technology can do.
A variety of industry partners have come in to provide cutting-edge technology to be able to get our work done. And we're already starting to see the results of that success. We began our journey with the Numbers team in Taipei. They're a talented and nimble startup dedicated to protecting user privacy. With them, we created a prototype capture application that contributes to an open-source library called Proof Mode that was first developed by the Guardian Project and Witness and has been used by human rights activists all over the world. With Proof Mode, we take the phone's GPS, network, and gyroscope sensors and embed the data from those sensors within each image. This helps establish the exact time and place that an image is taken. Then, in collaboration with HTC, the team at Numbers went the extra mile to leverage an open-source firmware library called Zion. With Zion, we take a hash of the image and metadata and sign it on a microkernel that runs on a trusted execution environment in an isolated area of the processor on the Exodus 1 phone. This prototype showed for the first time how outside of Android and iOS, we can establish a hardware-based root of trust and begin a chain of custody for each image as close to the camera sensor as possible. Then, with Textile's elegant developer tools and APIs, we use the IPFS protocol to stamp each file with a universal and survivable ID that allows us to upload the file to the decentralized web. There, we handed the baton to the team at Small Data Industries in Brooklyn. They are some of the leading experts in helping museums and archives leverage technology to meet the challenges of long-term preservation. They joined up with Postlight Studios in Beirut to develop an open-source command line interface and a series of APIs that orchestrate storage on a decentralized array of devices, from mobile phones all the way up to enterprise servers. To prove the integrity of this community-based storage, they leveraged the new Filecoin protocol. Filecoin first initializes secure storage by sealing the data with stacked depth robust graphs that create a proof of replication. Then periodically, the protocol uses advanced proofs of space-time to randomly select some leaf nodes of the encoded replicas and run Merkle inclusion proofs on them to demonstrate a file has been stored continuously over time and has not been tampered with or degraded in any way. This is the next generation of long-term web hosting. Without relying on a centralized node, we can conduct powerful audits on every sector of storage with permanent, verifiable, and succinct zero-knowledge proofs that attest that each server's commitment is kept. And different from any other form of blockchain protocol, with Filecoin, we achieved consensus not through wasteful computation, but through productive encoding and replication of data. In other words, this is a green and useful blockchain network that becomes more resilient and secure as more files are stored on it. But no matter how strong this cryptographic chain of evidence is, you still need human experts to analyze the contents of the files to determine their final validity. That's where the team at Holosystems came in to build our Verify module. Working with their teams spread across North America, Europe, and Africa, we built a flexible UI that allows experts to review photos and video and publish their analysis on their own internal permission ledger using Hyperledger Fabric on the IBM Cloud. Each expert's review is certified as an assertion and hashed on this private ledger. These transactions are then broadcasted with serverless adapters onto a trustless ordering system that uses a new integration we built into the lightning-fast Hedera consensus network. This allows a network of peers to create an immutable and time-stamped public record for each report without revealing its underlying data. Then, for users that have permission, we load the metadata from Hyperledger Fabric into a decentralized graph database called GUN. GUN stores a high-performance decentralized cache of the content across millions of devices, all just inside the browser. These clients synchronize the data using a deterministic, peer-to-peer, CRTD-based conflict resolution algorithm and secures every record with a cryptographic signature. This allows a user who's on a website or on social media to quickly check the ledger to validate the authenticity of any image that they see. This verification process is repeated again and again as more and more experts join to verify the validity of an image. Each organization's reviews and conclusions reside on their own secure, immutable ledger. So therefore, each assertion of an expert, each transaction of a hash graph, each view by a reader, they're all decentralized. And this ensures that there's no single ledger of truth. Instead, a community of experts keeps their independence and establishes consensus within a knowledge graph that evolves over time. That's why Starling is so valuable. It empowers people with technology, it brings experts to weigh in to restore trust in our images, but it always encourages end users to come to their own conclusions.
There are now engineers in 25 cities all working together, and they're cognizant that they're trying to build something that matters. And so they're being a bit more careful as they innovate so that we get the trusted system we all hope for.
One of the things that weighs very heavily on us is that the very tools that we are using to augment documentation can also be used to become tools of surveillance. And we can use the full power of cryptography to not only ensure that there's integrity in the process of storing the data, but also where needed that we can use encryption to be able to protect the identity of the people who provide us the information.
You cannot separate the science and technology from the ethics. So we're starting to ask in everything we do, not only how do we do it, but also why.
We're trying to take a methodical approach to allow us to learn the hardest lessons at the beginning with the experts so that we can then bring that understanding to a broader adoption of the technology.
We're not in a rush. The technology for image authentication is here. We're just not clear of what all of its implications are.
The important and impactful research and development problems are not confined to any existing discipline. but are at the intersection and union of many disciplines. It's about the coming together of engineering with ethics and law and journalism and the social sciences. All of these things need to come together to address the problem.
Engineers want to build things that matter. This project gives many engineers a chance to do something right.
As electrical engineers, we're part of society. It's only natural we try to make a positive impact, and we have the tools to do it.
I think we're sitting here in the aftermath of some pretty difficult years in which people have now started to really mistrust technology. And the key approach that we can take is to say, let's not be overly fearful or overly negative around technology, but instead just recognize that we have always had the choice to make good choices with technology. We've always had the choice to be able to implement technology in an ethical way. And the question is whether or not we ask ourselves how best to do that.
A lot of the work in blockchains is based on the fact that you need the public to trust the blockchain. As a result, many of the algorithms that are being developed are all public. Unlike traditional technology companies, there are no secrets here. And the way you achieve trust is basically by telling the world exactly how the system works. So this openness and strong desire to collaborate with new talents is fairly unique to this environment. I think that's why it's an exciting area to work in, because we're just at the beginning of starting to understand everything that technology is going to be able to provide.